Okay, now we're going to put the start up the Datalogger program itself, and we can see here that we've got, let's actually get this on the screen so it's centered well. You can see all the buttons. Okay, and I believe we're focused as good as we're going to be. I'm going to try to talk louder because now that the fan's running and the charger's running, it's a little bit of a problem. Okay, so the first thing you do is you're going to notice that this thing is not running right now. Okay, so what you're going to want to do is, while it's not running, you want to come in and enter the name of what you're going to want to put in for a database file. So this is Mike's old pack. Oops. Mike's old pack. Silver car. Okay, now this test number here is added to the end of the name, and this name is added to the end of the database file. So as soon as we start the program, what we're going to see up here is what the database file is. So once you put that in, you're kind of ready to go. Now it's important that your serial port is plugged in at this point. If it's not, the program will stop immediately. It won't run anymore, and it'll give you an error. So we're going to do it the right way. So basically now it's running, and go to the graph. You got the variable data, the cycle data, compare files, and setup. Okay. So we're going to start off by going to the variable data, and with this button up here, we can have this thing acquire all of the information to fill in this thing in. We can also do it by selecting down here. So here's the tech edit. So this data over here has now filled in this information here. We want to get the user variables. All of this information got sent, and it filled in all of this information. Up here, down here, we can stop, start, pause the charger. We can read the tech variables, user variables, program version, the last variables, and the 6 cycle pages that we can store in the charger. So the program version comes out here, and the easiest thing to do is to just hit get all data, and then it just asks the charger to send one thing after the other, and it's basically filling up the cycle data right now, which this charger has a few pieces of information in it, but not many. Once it's done, it stops beeping at you. The graph is waiting for information. The battery volts is not being read yet. So the next thing to do is decide if you want serial to be sent always and in 5-minute increments or 5-second increments. Now this is what I want. What's there is a 0, which is basically all of them are off. So we go down here, and the 72 is the translated version of this information, and to write it to the EEPROM, you do that, you hear a beep from the charger, and now it's basically sending information right over to our thing. Now the battery volts is 156.2, and the temperature down here is 71 and 69, so they're off scale here. That's why we're not seeing them. So if we go down here and double click on the 72, we can change it to 65 and hit enter, and now you can see the 2 temperatures. Now this isn't the right harness for this charger's calibration, so that's why there's a little bit of an error. But the bottom line is you can see the temperature. And these scales, all of them, are adjustable easily. So if you wanted to see with finer resolution, instead of going from 140 to 172, you're a little above 155, so you can come over here and go 155, and when you hit enter, it goes down there. And then you can come up here and say, well, I want the top of the scale to be 160. 160. So now you've only got 55 to 60. There's 5 degrees covering the 5 volts covering the whole scale. Now the cool thing about this is you can actually start, pause, and stop the charger from here, and you can clear the charts from over here. It tells you which run mode you're in, no delay, high current. It tells you the car profiles, a Honda Insight. You're not charging. And this is going to be the charge information once we actually start. So we can go over to variable data, and we've got the thing set up this way. Now what run mode do we want to do? Well, you have the ability to go over here and set the run mode. Now take a look at this. This is basically everything that you store in the charger. Profile, cutback volts for the 6 profiles. So cutback volts 1, cutback volts 2, cutback volts 3, cutback volts 4. Charge maximum volts for 1, 2, 3, 4, 5, 6. Minimum discharge volts. If you want to read what it is, you press the button and it reads it back for you. If you want to change it, you hit the right button, you increment or decrement it, or just type in here 135, and then you hit this to write it. The charger will acknowledge it by beeping at you, and then you can read it back and you see that the new information is there. And if you were looking at the charger, you'd see the same information there. I'm going to leave it at 130. So basically we come back here again, and then we'll write it again. So you got all that information here: run mode, start delay, interval hours, maintenance, run time, charge time. I spelled it out pretty much in plain English, so you don't have to try to figure out the abbreviations, because we've got all the room we need here. Sample time, temperature diff max, raw. And you're going to notice that you actually are going right into the calibration information, the technical data. So you can really mess up your temperature calibration and your current calibration. Here's the current calibration is 23 on this particular charger. If I change this, then the difference, the accuracy of your low current and high current readouts won't be as good as if you left this number there. That's why you shouldn't fool with this stuff. But I put it in here so we can access everything. You can even access what the power supply voltages were when we did the calibration. So with all the power supplies together, if we press read, you'll see it was 250.1. If you go 48 volt A, that's the one that's adjusted to a lower voltage than the rest. Go to B, you'll see that's 155. So basically you can actually see what this is, the 350 milliamp. You can see what all that information is, and any of these things up here can be changed. So you can actually change pretty much any one of these right from here. So right now we're basically interested in the options which we had just set up right here. We can also go and say, let's start a charge. Go over here to the graph screen, hit the start button, clear the charts. And now, if you look back here at the setup information, you'll see the actual data log path right here. Database file, Mike's old pack silver. And actually, if this was longer, we'd see run 2 at the end. I got to make this field longer. Well, normally you wouldn't have this long of a path, but it's possible. And this is the actual data log path again, which also does include the run 2 CSV. Now this is a real CSV file. You can bring it right into, you can import it into Excel as a CSV, and it'll go into the right columns, and it'll look pretty good. And you can go in and edit it. So if you've got glitches on your graph while this is happening, you can edit it and pull out those glitches, and then you can have a nice clean database. Now you can see we already are up to 161 volts, and our scale was reduced. So let's bring this down to 158, and let's bring this up to a more reasonable 175 or so, which we shouldn't hit right now. Now the way this graph works is every new data point adds 1 to the length of this file. The file is presently set up so you could have 22,000 entries into the file, which should be almost enough to get you through the 3-day complete cycles. But to let this computer sit there watching the serial data for 3 days seems like an overkill. You're really only interested in doing that when you're trying to diagnose the pack. Now, let's go to this gray line here. This is basically a very interesting, this is the rate of change. The higher this number, the faster the voltage is dropping or rising. And this gives you a very good idea of capacity of the pack. If you see a pack that discharges and goes way up to 130, 140, especially if it's in the linear portion, which is usually around 150 or so. And let's just expand this scale a little bit more. So we go to 140, 145. So basically we're sitting here watching this thing grow. Now the system status is updated when it comes in, but the user variables are where that information comes from. So if we want to compare files, it's another function. Let's stick with, let's not jump around too much. So variable data, we can basically look at what happened the last charge. We can read any of the variables we want, fill in all these tables. We can change the option bits. We can change the run mode. We can change the start, delay, interval hours. Any of these values can be changed right from here. Now the interesting thing is that you can change them while the thing is running. So for instance, let's say the cutback voltage for this particular profile was 166. We're now up to 163 and rising. So we could lower this so that we'll get there pretty quick. It's 163.8, so let's write that into there. And we'll see the graph. Once it hits the cutback volts, it will drop down, and there it goes. Over here you can see the current. So we're now in the topping zone. You can see that over here. And if we go back to the variable and we raise this value and write it, the charge is running, so it can't accept that new information. It's already past that point. So the only way we can get it to accept that information is to pause the charge and then start it over again. And now this time it's back up to 1021 as far as the charge current, because the cutback voltage of 167 that we set in there hasn't been reached again. So many of the variables can be changed, especially if it's an alarm point that you haven't got to yet. You can change it right there. So this is basically how you do the setup and how you get the thing running. The variable data you see. On here, the only controls you have are basically the ability to start, pause, stop, and clear the chart. If the cycle data is available, you'll be able to look at that here, and this is a little cheat sheet here that lets you see what the reason for stopping is in plain English. So over here, the charge stop reason was an 8. Voltage plateau detected. The discharge stop reason was 6. Slope threshold reached. That means that the rate of change was higher than what we allowed, and we allowed it based on the where is it? Slope diff max. So the average slope was increased by 40, and we said when it reaches 40 we're going to stop. So it was basically falling off the edge. Now this was an old scan. It's got nothing to do with what we're doing now. So basically it ended at 134 volts, which is good. So that's it. Pretty simple. It looks a lot more complicated than it really is. Now over here you have a report. The setup is where you put your name in initially, and it's the screen that we go to when we originally get there. And you'll see it's Mike's Old Pack Silver. The test file number for the file is 2. So let's say we decided we were going to pause for a second, and we just wanted to pause and then go right back and start the same database file. We don't want to have it start a new file. So this over here says new on restart. So if I press stop the program, we're not listening to the serial data any longer, and then I can come back over here and start it again. And then if we go over here and we look at the files, you'll see now it's run 3 rather than run 2. So it incremented this test counter, and so we've generated a new file. Now you can easily cut and paste the new file into the old file if you want to get a nice clean database file. But an easier way to do that is to switch this, which says append. So make a note here that we're in run test number 3 in Mike's Old Pack Silver. So now what we're going to do is we're going to stop, and then we're going to restart. And it didn't change this number. It's writing it in the same place. So append allows you to add the file that's generated when you restart to the end of the file you just went through writing. As soon as you upload your information here, fill this table in, this information down here becomes valid. Charging, topping zone, and so forth. Same with the options here. These options are nothing but the same options that we can see if we go over here to the options display. Okay, so that's about it. Now we'll stop this file in a minute, and then we'll go look at the compare files and see how that works, and then you'll have the idea of how to work this, and we'll also print out the pages and get into that.